everyone. Good morning. I am Srinivasa from VCUBE Software Solutions. Today we see an example how we discuss the concepts in VCUBE. So it is like, for example, if you want to find whether the given number is prime number or not. First, any program if you want to implement, first you should have the clarity on the requirement you want to implement. So for example, when I say I want to find the given number is prime number or not. So first you want to understand what do you mean of prime number. So every one of us know that a number which is having only one and itself as the divisors, we call that number as the prime number. So first we need to find the divisors for the number, and if those divisors are only two, then we can say given number is prime number. So here what I am trying to highlight is, when you are trying to implement some program, first you need to understand the problem and then you have to convert that into the Python program. So here my problem is like, I want to check whether the given number is prime number or not. So if I want to decide some number as a prime number, first I want to find the divisors for that particular number. If that number of divisors for that particular number is 2, then we can say the given number is prime number. So the first thing we need to do is, we need to understand how we can find the divisors for a particular number. So for example, I am checking whether the number 5 is a prime number or not. So as I told you earlier, first you need to find the divisors for this number 5. So mathematically, how we can find the divisors is, it is like we will start from 1 till that number, we will divide like this. So it is like 5 by 1 and 5 by 2, 5 by 3, and so on, like 5 by 5. So this is the way to find the divisors mathematically. So here it is like, if 1 divides 5 completely, it means when you divide 5 with 1, if you get the remainder 0, we call 1 as the divisor for this. And if you divide 5 with 2, if you get the remainder 0, we will call 2 as the divisor for it. So like this, you will find the divisors first, and then if the number of divisors for that particular number is 2, we say that particular number is the prime number. Now we will try to write a program for it. So generally, very first you need to read the number. You want to find whether it is a prime number or not. So first you want to read that number, right? So we will read the number like this. So input, enter a number. So here I am just giving a message to the user, please enter one number, like that. So here if you closely observe, input is the method given by Python which is used to read the data dynamically from the user when the program is running. And if you see, when you read the data by using input method, it reads the data in the form of string format. So but now we are discussing about the numbers, right? So we want to convert that string into the number. So I mean, though you enter 5 via input method to your program, so it will treat it like a single quote 5, because this is the fundamental behavior of the input method. So it reads everything in the form of string. So it is our responsibility to convert that into integer format, because we are dealing with numbers in this program. So we call this conversion process as type conversion. Okay, so now as I told you, first we want to find the divisors for that particular number, right? Mathematically, for any number, the divisors are starting from 1 till that number. So this is what I was explaining here. So now I take one loop. So before the loop, so we need to initialize one variable with 1. So here D means divisors starting from 1, I told you, right? So that is the reason I am initializing the D with 1. So which will go till that particular number. So here in our case, if you closely observe, if you read 5 into your program, the divisor starting from 1 till the 5. So the same logic I am keeping in Python terms. Okay, now, so where every, I mean, in the iteration, I am starting from 1 till that number I am going, right? So for every number, I do like this. Here I am doing like num modulo division d equal to 0. So it means here I am just dividing the number by using 1, 2, 3, 4, 5 like that. So with this, what I can get is, if that particular divisor is dividing this number with remainder 0, we call that as that divisor. So in that first, what I do is I will print those divisors. Okay, so very first I'm just printing the divisors of a particular number. Then we will see the next steps of the program, which is finding the prime number. So after finding whether some number is a divisor for that particular number or not, so what you want to do is to go from another, I mean, to go to another divisor, you need to increment the d. So this is mandatory step. Okay, so now what happens is our program will read one number and the divisor starting from 1, and we are checking here 1 less than or equal to that particular number or not. For example, if you read 5, so 1 less than or equal to 5 or not, it will check. If it is true, then it go inside and it do like 5 modulo 1 equal to 0 or not. If it is equal to 0, it is just printing that divisor, and the d will be incremented to 2. Now again it come back and it checks like 2 less than or equal to 5 or not. If it is true, then it comes down and it do the operation again, like 5 modulo 2 equal to 0 or not. So we already know 2 cannot be, I mean 5 cannot be divided with 2. So when you divide 5 with 2, the remainder is not 0. So it is not going inside the if block, and it is not going to print that. So this process will continue till this condition fails. This while condition fails, the process will continue. So here the output is like for example, if you enter 5, it just prints the divisors of that 5. So let me run and show you the output. So for example, if I enter 5, it is giving 1 comma 5. So because 5 is having only two divisors, 1 and 5. For example, if you run again and if you give some other number 10, so it gives the divisors for that particular number. So again, so now I'm just showing you how to find the divisors. But my requirement is I want to find the number of divisors of a particular number. So how can I do that is, instead of printing the divisors, I will count the divisors. So here I am not going to print. So I am just counting the divisors like this. So I mean, when I am running the program, by completing, I mean, by the time the while loop completes, I have the count of divisors for that particular number. So after coming out of the loop, I will check if the count is equal to, it means the particular number is having only two divisors. Then I can say given number is the prime number. Otherwise, I can say prime number is, I mean, sorry, the given number is not a prime. So this is the logic to find whether the given number is prime number or not. So let me run and show you the output. So for example, if you enter 5, as it is having only two divisors, it is clearly saying prime. So yeah, so this logic will work because we have the clean code here. So, and one more important thing I would like to highlight, when you are implementing some code, it is mandatory to make few things done. So it means, so it is not all about, getting the output. Your program should be having as much as possible less number of lines of code. That is one important thing. And your program should run fast, and your program should give accurate output, and your program should utilize the memory properly. So when you are implementing any real-time program, these all things are mandatory. So but if you closely observe to at our program, it is giving us the input, but there are some flaw in this, there is some flaw in this program. So first we will discuss what is the flaw in this program. So it is like, for example, when I am reading a number from the user, that number can be odd number, or that number can be even number. So mathematically, any even number will not be a prime number, correct? Though the user enters the even number, I am doing all these things to identify the number of devices, and then I am deciding whether the given number is prime number or not. So as mathematically we already know, any even number is not a prime number. So why I want to perform all these things unnecessarily, which is consuming lot of time. When you are dealing with very huge numbers, a very huge even number, then to find the number of devices, it takes a lot of time. That is the unnecessary process, right? So I can skip those kind of unnecessary things from my program. So what I do is, before going into the while loop only, I check something like this: if num modulo 2 equal to 1. So it means if it is odd number, then only you perform all these things. Then only you perform all the things, to identify the devices and all. If it is not an odd number, it means if it is an even number, you directly say it is not a prime, like that. So here what we are gaining is, if user enters the even number, we are not going to perform all these things to find the devices, and we are directly confirming it is not a prime number. So I will give you one example. For example, user is trying to find whether the given number is prime number or not for this number, for suppose. So he has given very big number, but this is the even number, very big number, and he tried to find it. If you closely observe, though it is a big number, you got the output within a nanosecond, because you are directly filtering it out here itself. If it is odd number only, you are performing all those things. If that is even number, you are directly saying it is not a prime. So like this, there are still there is a flaw existed in this program. So but yeah, for time being, you understand, right? When you are writing the program, how you can write the good program, and how you can implement some more performant program, and how you can implement a program with the less number of lines of code, and how you can implement a program where you can avoid some unnecessary checks and all. So like this, in VCube, we discuss everything in a real-time manner and the practical manner. We'll show you everything step by step to make you understand. A non-technical person also can easily understand the VCube way of teaching. So that's it.